So basically, just want to talk about what are word problems. So word problems are basically problems that are written in English, and they require you to perform many operations in order to find the answer. So basically, you need to translate the words in the word problem into mathematical equations. And on the right side, I have a few words that indicate certain mathematical operations. So there's certain words that are associated with either addition or subtraction or multiplication or division in word problems. So like with addition, you can have like sum or total, and subtraction, it could be like decrease or the difference. Multiplication is, twice, double, or the product, and division could be like splitting up or sharing equally. So those are a few key words you can use when you want to talk about when you want to convert the words in a word problem into certain operations or mathematical operations that could develop into equations. So first of all, I just want to talk about how to solve multi-step equations. So I just want to go through these steps, and then I have a couple of examples that we can go through on my notebook. And so basically the first thing you want to do is try to clear out all the parentheses, and you can do this by doing distributive property. And then you want to simplify each side of the equation. So you want to combine like terms on each side of the equation. And then you want to make sure that there's just one variable term. So if there's one variable term on the left and then one on the right, you want to somehow combine them by doing an inverse operation. And then you want to get the variable term alone on one side of the equation. So there'll just be the variable term on one side and then the rest of like the numbers or whatever on the other side. And then you're going to try to isolate that variable by doing different inverse operations. And finally, you can use substitution of whatever value you get for the variable and substitute it into the original equation to check your answer. But we'll go through this in a couple of examples, which are on this slide. So here I have a couple of examples that I want to go through just to solving multi-step equations. I'm just going to go ahead and turn into my tablet. So this is solving multi-step equations. So for the very first one, we had x plus 10 equals negative 5x minus 8. So with this, we're basically going to try to do the inverse operation. So right in this equation, there's no parentheses, so we don't have to worry about that. And then, but we do have to worry about isolating the variable term to one side, or having one variable term. So what we have to do with that is we have to combine the negative 5x with the x. So how we do that is by doing the inverse operation. So what we're going to do is we're going to add by 5x. And you have to remember to do this on both sides. And when you do that, we get 6x plus 10 equals negative 8. Now we have to try to isolate the variable term. So by doing that, we need to get rid of this 10. So we have to do the inverse operation, which is subtract the 10 from both sides. And here we get 6x equals negative 18. And finally, we have to isolate the variable itself. And the way we can do this is try to divide by 6. Since the x is multiplied by 6, so we have to do the inverse operation in order to get the x alone. And here we get x equals negative 3. Now, we got this as our answer, but we can check our answer by plugging in negative 3 into the original equation. So our original equation was x plus 10 equals negative 5x minus 8. So here we can plug in negative 3 plus 10 equals negative 5 times negative 3 minus 8. So on the left side, that'll be 7, and this equals negative 5 times negative 3 is 15 minus 8. And so then it equals 7 equals 7. So we see that once we plug in that answer we got, this equation comes out to be true since both sides are equal to each other. So our second question we have is negative 4 times 1 plus x, and this is plus 7 equals 3x plus 10. So in this case, we do have a parentheses to get rid of, the pair of parentheses. So how we do that is by doing distributive properties. So we're going to distribute this negative 4 to this 1, and then the x in the parentheses. So when we do that, we get negative 4 minus 4x plus 7 equals 3x plus 10. So first we want to try to combine the like terms on each side. So it's only the left side where we have negative 4 and 7 can be combined. So negative 4 plus 7 is 3. So we have 3 minus 4x equals 3x plus 10. And here we can go ahead, our next step is try to get one variable term. So we need to either bring the 3x to the left side or the negative 4x to the other side. So let's go ahead and do the negative 4x to the other side. So we have to do the inverse operation, which means we have to add 4x to both sides. And we get 3 equals 7x plus 10. And now that we have only one variable term, we need to isolate that variable term. And to do that, we need to subtract the 10 from both sides. So then it becomes negative 7 equals 7x. And we're just going to go over here, and we need to isolate that variable, and we do that by doing the inverse operation of division. So we divide by 7 on both sides, and we get negative 1 equals x. And again, we can check our answer. By plugging it in for x from the original equation. So negative 4 times the quantity of 1 plus negative 1 plus 7 equals 3 times negative 1 plus 10. So let's try to get a number. So 1 plus negative 1 is basically 1 minus 1. So we know that's 0. And that's plus 7 equals 3 times negative 1 is negative 3 plus 10. Now negative 4 times 0 is 0. So that's going to be just 7. And then if you add negative 3 plus 10, just 7. So this means that both sides are equal to each other. So we have the correct answer for x. So I'm just going to return to my PowerPoint. And here we're going to look at using these multi-step equations, but for word problems. So this is a little bit of a breakdown of the steps you need to take for these word problems. So first of all, of course, reading the word problem. You want to read it until you're able to understand what you're being asked for. And it's a good idea to usually highlight some of the info that's important. And it can also be really helpful to sometimes draw a picture, if possible. And usually in these word problems, you are able to define a variable. So you can claim, basically, you identify what you're asked to find, and you can define a variable for that particular thing you're supposed to find to represent the unknown quantity. And once you find your variable, trying to write an algebraic equation is the next step. So you're going to basically take down the sentences and the words in the word problem and try to translate it into math. So like I said in the first slide, we try to take certain words and translate it into mathematical operations. So those keywords can be used to find these mathematical operations. And a good idea is also to try to find if there's any relationships among certain quantities in the word problem. And finally, once you have your algebraic equation with your variable and whatever mathematical operations, you are able to perform algebraic steps to isolate the variable and find your unknown quantity, just like we did when we were just solving the simple multi-step equations. And finally, you can check your answer like we did by substituting your unknown quantity into the original equation, and just to make sure it sounds legitimate. And a good thing to do after with word problems is to state your answer in a sentence or a statement, like just to clarify what you found as the answer. So I have 5 examples because I think the best way to understand how to turn these word problems into multi-step equations is to have examples. So this first example is we have the sum of 4 consecutive odd integers is 840. What are the 4 numbers? So I am going to switch back into my OneNote. So here we have, this is the word problems. So this is our first example. So here we have the sum of 4 consecutive odd integers is 840. What are the 4 numbers? So here, so these are 4 consecutive odd integers. So I'm going to try to define a variable, and I'm just going to call this variable n. And n is going to represent the smallest integer that I start out with. So the smallest of the 4 integers. So, and since these are, so there are 4 consecutive odd integers. So odd means that it's going to be every other number. So since it's every other number, so if n is my first number, so that's my first number, then every other number means you have to add 2 to that first number, assuming that n is an odd number. So then n plus 2 should also be the next odd number. So that's your second number. And then n plus 4, you add another 2. That should be your third number. And then finally, you add another 2, and that should be your fourth odd number. So these are the numbers we're working with. But we know that the sum of those is 840. So basically adding all of these four numbers is going to get us 840. So how we can write this out is by adding all of them up. N plus 2 plus n plus 4 plus n plus 6. And that equals 840. So this is our algebraic equation we have. So right now, just like we did when we were solving these multi-step equations, is we're going to combine the like terms. We're going to combine all the n's and all the numbers. So we have n plus n plus n plus n. So that's 4 n's. So it's going to be 4n, and then 2 plus 4 is 6, plus another 6, that's 12. 4n plus 12 equals 840. Now, our next job is to isolate the variable term. And here we're going to basically just subtract by 12. And when we do that, we get 4n equals 828. And then to isolate n, we just divide by 4. And here we get n equals 207. So that's the smallest of the integers. So if n equals 207, then the next integers are n plus 2, that's 209. And then n plus 4, that's 211. And then the last one is n plus 6, that's 213. So we have all 4 of our integers. So that's one of the word problems that we're working with. So basically trying to convert the words into mathematical operations, and it requires a few steps to get to the answer. So I'm going to go back to my PowerPoint real quickly and show you the next example. So the next example is a medical center is planning to hire a total of 54 nurses and CNAs, which are certified nursing assistants. If the center needs twice as many CNAs as nurses, how many should they hire of each? So we're gonna try to work this out. This is a little bit more of a word problem since it's more related to real life in a way. So here, so it's example number 2, and we have the CNAs. So basically, we want to define a variable. So we have in the problem, it said, if the center needs twice as many CNAs as nurses, how many should they have? So we need to know the number of CNAs and we need to know the number of nurses. We know that the total of those is 54 according to the problem. So since we have a relationship between the CNAs and nurses, we can just define one of those variables. So because it says that the center needs twice as many CNAs as nurses, I'm just going to go ahead and define nurses as some variable n, the number of nurses to hire. So number of nurses to hire. So n is equal to number of nurses to hire, but we know that there's a relationship between the number of nurses to hire and the number of CNAs to hire. we know that the center needs twice as many CNAs as nurses. So that means the center needs 2 times the amount of nurses. And that's the number of CNAs to hire. So basically, we know that the number of CNAs that are needed to hire, which is 2N, plus the number of nurses that is needed to hire, should be equal to the total of 54 nurses and CNAs we want together. So that means we have this equation where it's N plus 2N equals 54. And then here we just combine the like terms on the left side. So we have 3N equals 54. And we isolate the N variable. Sorry, let me divide by 3, not N. And we get N equals 18. So this is equal to the number. So this means that 18 nurses. And then we know that 2N equals 2 times 18. And that is 36 CNAs. I'm not going ahead and checking these since I want to get through the other examples, but like we did in the first problem, you do want to go back in and just check by plugging in what N is and just make sure it comes out to be correct in your algebraic equation. And you're going to do the same thing in here. And this is this checking is the exact same thing we did with the original 2 multi-step equations we wanted to do. So I'm just going to go back to the PowerPoint. And we have example 3. So a cell phone company charges $30 per month plus 7 cents per minute. If Mr. T's January cell phone bill was $59.40, how many minutes did he talk? So let's go ahead back to the OneNote. So here we want to define a variable. What we're trying to find here is the number of minutes he talked. So we can define that variable as T. So that's a number of minutes talked by Mr. T. So we have in the statement that the company charges $30 per month plus 7 cents per minute. And that's, but we want to know how many minutes he talked in just one of the months, in the January month, if he paid $59.40. So this means that you have $30 per month, and you add that to 7 cents per minute, and that equals a phone bill of $59.40. So this is monthly bill. This is for January, and this is per minute charge. And then this is the initial month. Monthly fee. So this is our algebraic equation. And with this, we want to isolate the variable term. So what we're going to do is we're actually going to subtract by 30 on both sides. And we're going to get 0.07t equals $29.40. And to isolate t, we're going to divide by 0.07 on both sides. And here we get t equals 400. You can just plug this into your calculator. 420 minutes. So that means that he talked 420 minutes on the phone in the month of January. Okay. Now I just have a couple more examples. So in example 4, this is a little more challenging example. So you have this, the length of a rectangular garden is 3 yards more than twice its width. And the perimeter of the garden is 36 yards. What are the length and width of the garden? So here we have multiple operations. We have a relationship we can see between the length and width, and then we have the operation we need to use to find the perimeter of the garden. So let's go ahead, and in this case, it would be actually a really good problem to be able to draw a picture and visualize. So in this case, let's go ahead and draw a picture because I think that would definitely help us. So we have this rectangular garden. I'm just gonna draw a rectangle. And so this is our length and this is our width. So we know that the length of the rectangular garden is 3 yards more than twice its width. So since we have the relationship between width and length, we can choose one of them to be a variable, and we can define the other one based on that variable. So let's go ahead and just define W as the width, and this is going to be our unknown quantity. So, but the length can be defined in terms of the width. So it says it's 3 yards more than twice its width. So that's going to be twice the width plus 3 yards. 3 yards more than twice its width is the length. So and we know that the perimeter of the garden is 36 yards. So the perimeter in this case is going to be L plus W plus L plus W, which is going to be 2. So the perimeter, which I'm just going to call by uppercase P, is P equals 2L plus 2W. And we know what P is 36. And we know what L is in terms of W. So we're just going to plug that in. And we can just keep 2W. So this is a little more complex problem because we actually have parentheses, and we're going to have to do a few more steps than in the previous word problems we've done. So here we have to get rid of the parentheses first. We found our algebraic equation right here. So we want to get rid of the parentheses first. So we're going to distribute this to both terms in the quantity. So we'll keep 36 equals 2 times 2W is 4W. 2 times 3 is 6. And then we just have 2W. Now we want to have one variable term. So we're going to combine the 4W and the 2W together. So in this case, we're going to do 36 equals 6W plus 6. And we want to isolate the variable term with each other. on one side. So we can get rid of the 6 on the right side by doing the inverse operation on both sides. And we get 30 equals 6W. Now we are going to get W by itself by dividing by 6. Now we see that W is equal to 5 yards. And L is 2 times 5 plus 3, because W is 5 yards. And we get 10 plus 3, that's 13 yards. So the width equals 5 yards, and the length equals 13 yards. And that's our answer for this problem. This is a little more complex problem than previous ones we've done, but I think it's a good one to do. So we have our last problem, which is going to be about, we have example 5. So in this example, you have $65 in your savings account, and your brother has $140 in his savings account. So those are your initial amounts in each account. You deposit $15 per week to your account, and your brother is depositing $10 per week to his account. In how many weeks will you and your brother have the same amount of money? So here we have a lot of relationships, and so we need to definitely break down this word problem. So I'm going to go ahead and go to the OneNote. This is our last example. This is example number 5. So here we want to have a variable. So here what we're trying to find is the number of weeks that until your brother and you will have the same amount of money in your accounts. So let's just write out that variable. Let's just call it W. That's the number of weeks you and your brother have, number of weeks until you and your brother have the same amount of money. So basically the equation, the general form of the equation we're going to have is we want to know at what point your money equals your brother's money. Okay, and basically what we can do is we have, for your money, we have your current balance, which is 65, plus your new deposits. And for your new deposits, that is basically your amount of money times number of weeks. Now for your brother's money, he also has a current balance. It's different from yours, but he has also a current balance. And that is going to be 140. So for the new deposits, for your money, you're depositing 15 times W, because we don't know the number of weeks. And then for your brother's money, you have the current balance of $140, and that's also added to the new deposits. And your new deposits are going to be also amount of money times the number of weeks. So that's, but he's depositing $10 per week. So let's go ahead and just simplify this into the actual algebraic equation. So here we have 65 plus 15W equals 140 plus 10W. So we want to get one variable term. That's the first thing. We don't have any parentheses. There's no combining of like terms on each side. So right now we just want to get one variable term. So what we can do is we can get rid of the 10W on the right side. And we do that by doing the inverse operation, minus 10W on both sides. And we get 65 plus 5W equals 140. Now we have to isolate that variable term, and we do that by subtracting 65. And we get 5W equals 140 minus 65 is 75. Now we want to isolate the variable term of W. So we divide by 5 on both sides. And we get W equals 15. So that means it takes 15 weeks. And that is our answer. So basically, as you can see in these word problems we did, we basically tried to translate certain keywords in the word problem and convert into mathematical operations or find relationships between things we wanted to find out in the problem and with the information we also had in the problem. So a lot of doing word problems is being able to understand and convert into mathematical equations. And then doing the multi-step equation, that's algebra. Something that, you use the application. Word problems are the application of learning to solve these multi-step equations. So thank you for listening.